Hello and a warm welcome to my session Azure DevOps Multistage YAML Pipelines, the top 10 features. My name is Marc Müller. I'm a principal consultant at Fortecture and we are focusing on DevOps and enterprise architectures with Azure DevOps and Azure as well as .NET. Today's session is all about my favorite 10 YAML pipelines features. As you might have guessed it, we are just going through them. For sure, we're not able to do a deep dive for every specific feature. It's rather an overview and to show you the potential of those features and how you could improve your DevOps pipelines with it. So let's get it started and start with the first feature. So first of all, I'd like to talk about YAML itself and its capabilities of having true configuration as code for your pipelines. So if you have a quick look at the pipeline challenges we are facing, is that we actually need configuration as code. With the prior functionality of having classic build and classic release, we did not have configuration as code. So it was inside some entity in Azure DevOps and not directly related to any source code repositories, to any branching, etc. So normally, code changes might affect the pipeline definition. So if you add new features, change the frameworks, etc., you often need to adopt your pipeline accordingly. So if your pipeline is now coupled with your code, lives in the same branch, can be developed in the same feature branch, this is the true benefit of having always the right pipeline to your code version. In addition to that, if you want to build a very old state of our application, like having a bug fix release of an old version, this was a big issue because the pipeline might have been changed in the meanwhile, so you ended up cloning your pipeline over time to be able to build the old versions of your applications. So this is no longer needed since it is in your code repository. Always, if you check out an old branch, you have the corresponding pipelines at your hands and you're able to build it again without any changes and without a headache. Then we can work towards the reduction of code duplication. So if you're using now code files can be linked, and we will have a deep dive into that when we're having a look at the templates feature in the Azure YAML pipelines. Last but not least, the validation is a very important part of pipeline development. So normally you have a well-sophisticated review process with your pull request ecosystem in Azure DevOps. So now, since your pipeline is living in your code, you have the same functionality for pipeline changes. So normally you create a new feature branch for adding or changing something in your pipeline, and then you will have your normal pull request review workflow available for your pipeline changes. If we have a quick look at the code editor for the YAML pipelines, you will notice that here on top we will see the branch the current pipeline is in, and as soon as you change something and save it, you will be prompted to create a new feature branch or use an existing one, or even though directly create a pull request in order to review and integrate your pipeline changes back into your master branch. So if you have a quick look at this YAML pipeline definition, what is it all about? So a pipeline consists of one or many YAML files, and it lives in the same branch, as we already heard, as your code changes. And you're able to use the pull request workflow and the policies, the branch policies defined in your repository to define a fully featured review process. So why should you care about? Now you have true configuration as code for your pipelines. You always have a matching pipeline definition to your code changes, and it's basically the feature you always wanted to have. So now let's move on and have a more deeper look into it, how you could use this new functionality of YAML for your DevOps pipelines. With YAML pipelines, you gain a lot more flexibility. So let's have a quick look about the challenges we're facing. So normally it's not always this very simplistic view of one CI process providing artifacts to a single CD process. You normally have much more complex definitions of it. You need to have multiple processes creating artifacts, using them, etc. Linear staging is often not enough. So normally you don't have this very streamlined dev test prod. You normally have a feature branch you're developing in. Maybe you want to have a feature branch deployment for verification and approval, going back to master, deploy it into different stages. So you want to be flexible with that one as well. And often we had the requirements for pipeline chaining. So you have different individual pipelines, but at the end you need to chain them all together in order to build something big, and this wasn't easily possible with the classic builds and release. And the pipelines as well need to produce and consume artifacts. So you could only produce artifacts in the classic build but not in the release. But what if you're creating something in a release and you want to provide that as an artifact, as a pipeline artifact as well? Now with YAML, it is possible, and it looks the following. So if you have a multi-stage YAML pipeline, you have the same concept as you already had. So basically, we are creating a pipeline out of tasks, combining them in a job, and having one or multiple jobs in a stage. So the job is the thing which runs on an agent, and if you need to have different agents because if you have different physical locations, you have different setups like VMs with the build tools and VMs for just releasing it, you will end up in having multiple jobs as well. With multi-stage YAML pipelines, you can pretty much combine them as you would like. So you can have a stage with multiple jobs depending on another stage, and for there on you fork it, so you run two stages in parallel, you join them as well afterwards. Maybe inside a stage you are forking the execution and parallelizing the job execution. So it's pretty much whatever you want to do, you are now able to do with YAML pipeline. Even though the build chaining is now easily possible, so we can easily use two multi-stage YAML pipelines triggering each other's, or the one is using the artifacts, the pipeline artifacts built from the others. So when you have a look at the best practices, how do we use this flexibility normally? So if we deploy something, we normally have a base infrastructure deployment, which means that we need to set up the base infrastructure, like having a SQL server, where we are later on deploying the databases. We need, for example, key vault infrastructure and so on. So first of all, we are creating a CD definition with YAML pipelines, and we are also doing a staging, because if you need to set up infrastructure like SQL servers, Kubernetes, etc., you want to do the same thing for dev, test, and prod as well. We are heavily using templates for this, because you don't want to repeat yourself. And based on that, when we want to deploy the application into that base infrastructure, we have a dedicated pipeline going on. So then we are using a CI pipeline to basically build our application. This one is producing the pipeline artifacts. So we are able to consume those artifacts in order to deploy it to our target resources in Azure. So here we have this build chaining or pipeline chaining when we are using the pipeline artifacts created by the CI build to be used in the CD, in the continuous deployment pipeline. Here normally we have this staging, but as I already told you about, it's not a very linear one. So we are often using this forking. Is it from a PR build? We can do a PR deployment for validation, for approval. And if it's coming from main branch, we're going through testing, pre-prod and prod to deploy our application. So let's talk about secret management in YAML pipelines. When you're working with YAML pipelines, secrets are not part of YAML. The problem is your YAML definition is stored inside the source control repository, which is a public search index. Everybody can access it. So there is just no place for secrets at all. So therefore, we need to reference those secrets in the YAML pipeline instead of defining it inside YAML. So these links we can see from two perspectives. So we need to distinguish between secret usage and secret management. So normally there are only a couple of few people managing the secrets, knowing them, but the pipeline administrators do not know the secrets. They just need the permission to reference them inside their pipeline. So how do we do that inside Azure DevOps? If you have again a look at our deployment overview, basically every time we're accessing a resource, we need to access the secrets to be able to configure the application or access Azure or any other target environment. So we need to use secret providers inside our continuous deployment process. Those can be secret variables, variable groups, key vault, through variables groups, key vault directly, or even though managed identity if you want to go passwordless. Okay, so how does Azure DevOps deal with it? So first of all, notice the red lock because there is no place for secrets inside YAML files. We can define secret variables outside the YAML file in the pipeline settings. We can also define variable groups containing the secret variables. And for deployment targets, we usually use service connections. So service connections are for when an agent needs to access a target resource. For secret variables, so variables you need to use inside your application configuration, there is another option. So we could use a key vault link inside your variable group to access your key vault in Azure and just use the values as a normal secret variable inside your pipeline. So the pipeline agent itself, for sure, the yellow log during runtime, it has access for sure, otherwise it wouldn't work. But logging is safe, so whenever you have a script accessing secrets dealing with it, and if they would be printed to the command line, they are masked, so there is never ever a log stored with your secrets in it. Okay, so let's have a quick look how this works. So if we use variable groups, we can define the secrets in there. So here is a very simple pipeline in Azure DevOps, and here you can see that I'm referencing groups. So if you go to library, you can create variable groups, and you could just create variables and secrets. But here especially, you can say link secrets from an Azure Key Vault as variables. So you put in your subscription, add your key vault to it, and then you're referencing the secrets managed in Azure Key Vaults to be linked to your variable groups. So from now on, my pipeline has access to this variable stored in Azure Key Vault. So to access the target infrastructure, we normally use service connections. So service connections, on the other hand, is also just a reference. So if you have a look here, normally I have a variable defined pointing to that service connection. So if you have any deployment step, like ARM deployment, for example, this needs an Azure Resource Manager connection. So it's just a reference to something managed inside Azure DevOps. So if you go to your project settings, you notice here service connections. So here you are able to manage all your secret connections to your target infrastructure where the agent needs access to. So this is an example for an Azure connection, but you have a lot of built-in credentials for different targets, even though you have a general or generic service connection where you can simply put in username and passwords to be used by your agent for your deployment. Let's talk about templates. When you're dealing with YAML pipelines, you often deal with a lot of code duplication because you're reusing the same tasks over and over. You have 10 different ASP.NET Core applications, so it's basically the same thing. So you don't want to copy paste them because if you change something, you need to change it 10 times. So the same combination of tasks should be reused, And this is what we call a template. So in order to copy paste those tasks, we are referencing a template. But if you're outsourcing this group of tasks, you need to be able to parameterize them, because normally the project changes, some file structure changes, you need to use different settings as well. So parameterization is very important if you're working with templates. Then we need to deal with different versions of templates. So if you have centralized templates, for example, you are evolving them, you are developing them, and you need to make sure you're not breaking other existing pipelines using them. So versioning is also a very important requirement for using templates. Last but not least, in big organizations, you have a centralized management of those templates. So you do it once and all the development teams will access them or reference them in their pipelines. So what can we do actually with the templates? So there is a bunch of things you can create a template for. So first of all, it's steps. So this is the group of tasks you want to reuse, but you could also create a template for a whole job. So a job containing of different or many jobs being together inside the templates using there a couple of tasks. You can even go one level up. You could create stages templates, so a full stage containing different jobs, different steps inside. And last but not least, you can also create templates for variables. So basically, if you have a bunch of variables which are always the same, you can extract them into a template and just reference them. So then let's start in a first demo to see how we could use those templates. So as you can see here, I'm quickly zooming in. This Hello World pipeline looks pretty simple. Why? As you can see here in the steps, I'm referencing the two pipelines. So creating a web application is always the same thing. And I thought, why not creating a pipeline for that? So here we can see that I'm just referencing another YAML file, which is located in my Git repository. So I created a pipelines folder, created here a template, build and package web. And as you can see, it's just a steps template where we have the different steps needed to compile my web application. So it's using .NET Core, installs it, builds it, and tests the application. And last but not least, it publishes this application. So as you can see here, there is a parameters section. So whatever I need to define is a parameter. So the parameter is used by this parameter expression syntax, and I can just put in the parameter values inside my task definition or the pipeline definition in general. In the caller pipeline, you see that I'm using this parameter section to provide the values of my specific pipeline to be included in this template reference. So here we can see a special template. So you notice here this add syntax, and this one is targeting to another repository. This is this centralized approach I was speaking of. So in order to have a centralized repository where, for example, here I'm doing the build versioning the same way for the whole company, I was creating a dedicated Git repository. And inside this dedicated Git repository, I'm creating my company-wide template. So we see here, this is my template for the build versioning because it should be done the same way for the whole company. So inside my pipeline, I can reference that repository as a resource. And as you can see, it's not only the name of the repository, it's also a reference tag. Here you see that I can have a specific version of it. So I'm always using V1 of this template definition. And if someone develops a V2 of it, I'm not bothered because my pipeline is using this specific version out of it. So templates are a very nice feature, but we can even go further. So by extending from a template. When we are using the templates, it's often that we just need a couple of steps which are different, but the rest is the same for the whole company. So actually, it's sometimes hard maintaining all the different pipelines on your own. So in which order do I need to take them? For sure, you could create a template which again references the template, but it could be easier. So it's often a decision between flexibility and complexity. And with the extend from pipelines, we can do the same thing as we are doing in coding. We can inherit from a pipeline and just define a couple of custom steps to it. Let's have a look. So here you see another pipeline definition. And if we scroll down, you see here a special keyword, an extends keyword. So this pipeline inherits from another template. So it's basically like using a template reference, but here I'm extending it. We see that I still have parameters, and they are called build steps and publish steps. So what is all about? Let's have a look at this template. So this template pretty much looks the same. It's a CI build job template. I have parameters, but it's kind of a special parameter set. So as we can see here, it's an array of build steps. So I can inject other build tasks, build steps into that pipeline. So here we see that I need to make sure that always the versioning is executed first. Then we are doing some scripting here. I just was mocking some security scans. And then the user of this base template can insert build steps. And for example, here, I omitted that they can use command line scripts. So you can inject any script or any step you want except a command line script. And you can have your own build steps and you can have your own publish steps. And here I make sure that after build and publish, I'm using another template to ensure all the tests were run. So it puts that to another level of really having a base template for your company and just using it and inserting your special steps inside this base template. And for example, here we see that we use the same template again as a build step, that we build and package the web, but everything around it for versioning, security checks, and making sure the tests were executed is inside this base template. So extending from pipelines is very nice, but we can go even further by using pipeline decorators. So if you use the pipelines, the security standards still need to be adopted by every pipeline. For sure, there is another functionality. You can enforce something to use a pipeline extension in order to be able to deploy, but maybe you don't want to rely on that or cannot rely on that and still want to make sure that nobody forgot the critical checks and tasks to be executed. It could be really a company-wide policy. You want to execute a dedicated script. You want to run a security check, for example, every time there is something built or deployed. So this centralized management of critical tasks and scripts is a thing we can do with pipeline decorators. So let's just start in the demo and I explain how it works. So here we see one of our pipelines and quickly make sure it's big enough. So if we go to last execution of this pipeline and we go to logs, we will see that we have here some decorator scripts. So there is a task, a step being run. It's currently just the hello world output. I'm just putting a line 12 decorator script execution to the command line. But this could be any task, any scripts running to make sure your security is okay, that something is validated, etc. This is not part of the pipeline. You won't find this decorator script in the pipeline definition. So it is really enforced by the company, by the enterprise, executing this dedicated script. So how do we do that? What I did is I created a demo extension, in this case, a pipeline decorator extension. and deployed it to my Azure DevOps instance and activated it here. So what is this decorator all about? So first of all, I need to create a standard VSS extension and defining it as a decorator extension. So you can see that here, this is the type, it's a pipeline decorator, and here it's basically again a template file being referenced, but not from the source code repository. Instead, we are using that from the extension itself. This could also be a very complex template we are using, but it's just packaged inside this extension. So here we see my decorator, and it's pretty straightforward, so it's a simple PowerShell task. I'm just writing to the console, but imagine you could do whatever checks you want to do here. What we also can see is that I used this expression syntax with an if statement. So maybe I don't want to run it every time, just where it makes sense. So here I'm filtering the team project that it's only run in my YAML pipelines demo project, and I make sure that a specific step has been inserted. So here, because it's it's loading at the very first point the template is the pipeline is executed, you can only deal with those GUIDs of the task, but this is the .NET Core task. So here, for example, you could think of, if I'm running a .NET Core compile task, I always want to make sure that you also executed unit tests and that there is at least one test result, otherwise I'm canceling the build or something like that. So you're able to really filter what and when your decorator should be executed. So you just install this extension and then it is inserted magically here as a post-build or a post-pipeline decorator every time you're executing a pipeline in your Azure DevOps project. So now let's move to something different, environments. So what challenges we are facing again with pipelines? So it could be that we need to add some validation logic, some approval logic to our target environments. And this validation and approval logic should be defined outside the actual pipelines. It could also be that multiple pipelines deploy to the same target location, to the same virtual machines, to the same cluster stage, and you want to have the same validation and checks being applied to them. Also, maybe you are interested in what was the latest deployments, what has been deployed to my target environment, and you need some kind of overview to see all the deployment processes towards your target. Last but not least, there are also special deployment actions. Maybe if you're deploying to a Kubernetes cluster, you could do some special deployment strategies like a canary deployment and so on, and this could be defined on this environment with specific capabilities like knowing that you're deploying to a Kubernetes cluster. So let's start with the demo then and see how we manage those environments. If you open again a YAML pipeline, if I'm scrolling down to my Hello World app deployment, you notice here I've got a deployment job. First of all, a deployment job is a special job. It has more capabilities, it doesn't download source code, etc. So it's really meant for deployment. On a deployment job, you see here, you have the option to define an environment. So you link the deployment to a specific environment. On the left-hand side in your menu, you see environments. I already did that. Let's move over. And here we see all my environments of my demo, and we can also see here this Hello World deployment. We have an overview of what has been deployed to my target environment, in this case my Hello World web application. But let's quickly create a new environment to see what options we have. So let's create a demo environment, and here you can see we currently have a generic one, no resources, and we have two specific ones to deploy to Kubernetes or virtual machines. So those are natively supported by Azure DevOps, and you gain a lot of new functionalities. For Kubernetes, you have specific deployment strategies. For virtual machines, you can place an agent directly on the machine and make sure every VM in your cluster, for example, gets deployed from inside out, that the agent is really placed on your virtual machine. So let's quickly move on. And here we notice that we can define security for sure, like every other resources in Azure DevOps, but we also have approvals and checks. So here we can say, okay, I'd like to have a manual approval, like my boss needs to approve before we go to production. We could say it's only allowed with branch control to deploy from a defined branch, like main branch or release branch. We can make sure we're only doing a deployment during the business hours so that everybody is there. If something happens, everybody can react immediately. We can evaluate artifacts. This is currently only possible with Docker containers, so we can inspect the container which is being deployed to make sure all the things are right. We can create logs that only a single deployment is taking place, that if you have multiple pipelines, that they are not overtaking or deploying inside the same environment. So you can do an exclusive log for a specific pipeline until it is finished. You can invoke Azure functions, so any REST API can invoke as a check. For example, you're requesting a REST API from your monitoring solution to see if everything is okay. So if your pre-prod environment is okay without any errors, you're able to go and proceed to your production one. Same thing for REST API, and Query Azure Monitor is basically also a REST call, but dedicated to an Azure Monitor alert, and here you can also check if everything is okay before going to production. And last but not least, we see here this required template. This is actually this inheritance model of templates. You can make sure you're only allowed to deploy if you inherited from that specific template, and make sure the company policies are applied. As I already told you, deployment jobs can do magic things for us. So they are meant to specifically deploy an application with a lot of additional functionality. So let's see what challenges we want to solve with them. So if we want to deploy something to our target infrastructure, we often want to use a special strategy. So like doing a canary deployment, first of all, deploy 5% of the new application usage. Then we want to increase the deployment count of 10% of all user traffic towards our new version, 50%, 80%, 100%, or something like this. So the problem with that kind of strategies is that we often have a very complex control logic in our pipeline, and it gets cumbersome maintaining it, getting to know what's currently going on, etc. So this should be simplified. Often these deployments need pre and post actions, deployment steps, validation steps, etc. And it would be neat if we could have something built into Azure DevOps multistage YAML pipelines to support us doing so. Yeah, let's go to the demo and see how we're going to deal with it. Okay, so in this demo, I want to show you a quick canary deployment to Kubernetes just to show you the capability of this deployment job. So I opened an already executed run. And what we can see here, I'm deploying the so-called greeter service to my Kubernetes cluster. And you see there's a deployment, then another one, then a manual validation, then another deployment, and then a manual validation, and so on and so on. So what I'm doing here is exactly a canary deployment. So I'm publishing a new version, but only for 25% of the traffic. If this is okay, then 50% and so on. And here this manual validation step is just for demo that I really need to click OK, everything looks good. Normally this is automated with your monitoring tools. You're actively watching your deployment. Is there any error? Can the user still do their workflows, etc.? And you won't do that manually. But for demo purposes, I did so. So how do we define that? It looks rather complex, but actually it is not. So if you go to the template definition, you see that I'm again using a deployment job. And here you can see you can use different strategies. So in this specific case, I need to link it to an environment. So I have here a specific environment, and this is of resource type Kubernetes. So this is important to see that here environments and deployment jobs play together. And for Kubernetes, I have these capabilities of doing canary testing. You can see here the increments. So I'm starting with a 25% traffic deployment, then a 50%, and then a 100% deployment, so that every traffic at the end goes to the new deployed version. So as you can see, all this complex logic on how to deal with pre and post steps validation is done in this deployment job. So here you see you have a pre-deploy definition, then you have a deploy definition, you have a post-route traffic definition. So this is where I'm doing the validation. So normally, again, you would just call your monitoring tools to automatically check if everything is okay. And for sure, you can also have event handling. So basically, if a failure happens, what to do, maybe a rollback, whatsoever. And in case of a success, you could do also some follow-up actions in your deployment. So long story short, have a detailed look at this deployment job because it includes a lot of functionality. It's not only this run once, you can easily build up complex deployment scenarios by just using this deployment job functionality. So now let's move over to infrastructure. You know, pipelines run on an agent, and this agent is part of a VM, for example, and you need to maintain those agent infrastructure VMs on your own, or you use the hosted ones. But there are a couple of challenges. So normally you want to have your dedicated tools, you want to have your specific version of your compiler, additional third-party tools, etc. So you normally end up managing VMs. And if you do so, you need a lot of storage, you need tools to manage your VMs, etc. So actually, it's not that easy, but there are great tools for that. Also, the VM snapshot is not integrated in the Azure DevOps pipeline standard process. So normally you would need to reset your VM in order to have always the same initial state. So where do you store your VM configuration? For sure, again, there are tools for it, but there is something easier. So if you have a look at modern Docker environments, so Docker is actually the thing you want to use. Docker is lightweight, Docker is fast, and it provides you all the things you need actually to define your CI environment or deployment environment. So this cool feature Azure DevOps has to offer are container jobs. So instead of using a dedicated VM, you could use a standardized VM just containing your agent in it, and then use a Docker container you define with a Docker file, add all your specific tools, and run every step inside this Docker container, and you don't need to change a lot in your pipeline. So let's have a quick look on how to do that. Here we can see a very, very simplistic Hello World compilation. So I'm just compiling a .NET Core application. So you see here down there the steps, the two tasks, we do a restore and a build. So we don't do that on the VM where the agent is installed. We do that in our custom container. So I created a custom container image with just my tools I want to use, and I'm referencing it here by using this container property. So what happens now is those steps are not executed on the agent VM itself, it's rather forwarded into that container. So Azure DevOps starts up your container, executes every step inside the container, and after you run, your container will be deleted, and the next time you start with a fresh container. So simple as that, adding one line of code container, and the rest of your pipeline stays the same, but the steps will be executed inside your container. So if we take that a little bit further, is that we normally want to do a shift left. So it's very complex to set up the whole infrastructure. It needs time and so on. So what we want to do is to test as much as possible on the left-hand side on our CI process on the compilation part of it. So maybe we also need to target multiple versions because our application needs to run on different, I don't know, SQL Server versions, etc. So it's normally quite cumbersome to set up those testing environments. So what can we do? So we could use this container functionality and extend it by another feature called service containers. So service containers is not the container where your agent process runs in, but you can add multiple additional containers to be part of your pipeline. So in this case, what we do is we run, or first of all, build our application into a container, and then we use additional helper containers like a SQL Server container to actually be part of a test environment inside this pipeline without creating VMs, without creating resources. It's all taken part inside this pipeline run, and it creates a dedicated network for you. You can run them in parallel, etc., etc. So a really nice feature, and I want to give you a sneak peek to it. Let's have a look at my pipeline run. Here you can see I have two stages, a build stage and an integration test stage. And inside this integration test stage, we have a test on SQL Server 2017 and 19 as well. So it all takes place in my CI pipeline. So it's really a shift left for integration testing. And let's have a look how I did that. If you have a look at my definition, we scroll down to the integration test stage. And here we can see that I am first of all defining a strategy matrix. So I'm running the same job for 17 and 19 version of a SQL Server. I'm using here, in addition to the container property, the services properties, and I'm spinning up two additional service containers, a SQL Server with the corresponding version, and an API container, which is my application I built in the build step before as a container, and I'm using this container now for integration testing. So the steps are pretty straightforward. I'm downloading the artifacts. I'm doing a DB schema deployment because the DB is empty. So I'm using SQL Server database tool with SQL package to do so. And then I'm just running some data initializer tests to create data on the SQL database. So as you can see here, it's pretty straightforward. There's a server named SQL and a server named API. Those are my containers in my dedicated Docker network inside this pipeline. So basically, it's just using a dedicated network, spins up all the Docker containers. I can access them through the Docker DNS and then run my test with, in it and then destroy everything after the pipeline finishes. To do so, I defined resources. Here you can see I'm defining multiple container resources. So I'm defining a 2019 resource, 2017 container, my API container, which has a dynamic image name because I'm building it in the first stage. And last but not least, I've got a worker container where I deployed all my worker tools like the SQL Server database tools, etc., to deploy it to my target container. So that's all you need to do, and you have a fully featured integration environment with Docker containers inside Azure pipelines. So now let's move on to the last feature I want to present you. It's the traceability. Traceability in Azure DevOps for me is a very important topic because this is the huge benefit of using Azure DevOps because everything comes together in a big database. You have your big data storage and you can combine, link everything together. So talking about pipelines, normally you are interested in what code changes, what work items are associated with the pipeline run. So you don't want to do that manually because it's error prone. If you have a system with Azure repos and Azure pipelines, which is able to link your work items to commits, get a change set of the included changes inside your pipeline, you want to make advantage of it and use that to generate, for example, release notes or provide some additional information. So let's start with the last demo and use this available information to create release notes. Okay, let's switch over again to Azure DevOps. And as you can see here, normally if you have a build run, you see the related items. So we see that we have 6 related work items towards that build, and we also have some artifacts, etc. So now we want to make usage of this and include that information provided by the pipeline system into creating release notes. So basically, this change set, this links is already there. There is an API for it. We just need to use it. So what we normally do in a project is we somehow generate release notes. In this example, we are using the Azure DevOps Wiki. So every time there is a deployment to production, we are adding here a new item in our release notes wiki. And if you go to the details, we will add all the information based on that pipeline run. So you see the build number, you see the included pull request for this production release, you see the work items. We added dedicated fields to our process templates to have beautiful release notes. See the tags, who is assigned to it. We also can see the commits which are associated. We even see the files which have been changed in order to release that. So we put everything together in this wiki. So how do we do that? Again, everything is already there in Azure DevOps. So the pipeline system is calculating the diffs. For releases, you need to do a little bit of more calculation because you only want to have the diff of that particular stage. So if there was a release to Q&A and it was rejected, the next production release should do the difference not to the latest Q&A release, but should calculate the difference to the latest production release. So what we did is we created a template for doing so and added a bunch of marketplace extensions to it. You could do that on your own, but I normally do not like to reinvent the wheel. So there is a release notes generator which exactly uses this API provided by Azure pipelines, and then you can create markdown files of it. You can upload the markdown files to a wiki, etc., and end up in a solution like I've shown you for showing the release notes of your releases inside your wiki. So we already come to the end of my session. Thank you a lot for your attention. I hope I could show you something new, some new ideas of how to improve your DevOps processes with Azure DevOps. If you have any questions, don't hesitate to reach out to me by email, by Twitter. And yeah, hope to see you soon again. Bye.